Welcome to Confidence Coin Getting Started tutorial. Let's go to the GitHub page. In here you can see all the developer tasks. I will be adding new tasks as we progress the development. Also, if you need to talk to me, contact me on the Coco Developers and Designers Facebook group. It's the best way to reach me. Alright, so let's clone this repo. It needs to be a recursive clone as I'm using submodels. Okay, now let's open it in IntelliJ. I'm on Windows machine here. For project, Coco, right? It's a Gradle build. Yeah, use auto import. Looks good. Sure. Yeah, add roots. Okay. So we have the core model. It shares source between desktop and the pool, which are desktop is the client, pool is the server side. Well, obviously. Also, there are some libraries. Database is to handle all the Postgres setup. Also have the core file and well, I'll take those in short, but core and pool files that should get you started with all the schemas settings. And let's start with first running system. Okay, so I'm going to pool server. Let's launch it. Okay, and desktop. It's the desktop wallet client. It's using JavaFX. Let's launch it first. Okay, first thing is the screen for creating a password for the wallet. Just type some dummy password for now. And next, I have the option to restore my wallet using my private key or create a new wallet. And then it automatically generates a wallet address for me. This is my public key. I have the option to export the wallet, to copy my private key here. There is the mining screen, which I can start mining. And there is the pool name, which at the moment not implemented, but it's supposed to take the pool from the Royal network. Okay. At the moment when I'm finding a share, show you the Postgres. So in the pool, I have the shares table. It has a unique key on block, mine date, and block ID. So it makes sure that no shares were submitted more than once. And then there are workers. So this worker found 2 shares. The balance is supposed to be, well, actually, yeah, it can be null, I guess, at the beginning. And when the pool finds a block, it needs to reward all the workers based on their shares, then go and reset the worker balance, or I think you can drop the table as well. And obviously truncate the shares table. Yeah, truncate the workers and the shares tables. Okay, So in terms of what implemented so far, link to crypto is the DTP. It's not implemented yet. Send coins, I have one transaction implemented. Need to implement all the rest of them. This part not tested, by the way. The balance needs to be fetched from the pool. This is a dummy balance at the moment. The copy button works. The export wallet works. Smart contract, you need to add here a URL to your smart contract. Then you load it. And then you review your smart contract. And, oh yeah, we'll need to think about this entire thing. Yeah, and the pool name that we discussed earlier. Okay, so let's look at the source code. Let's start with desktop, I guess. The first thing is the root screen controller. Is the entrance to the application, the public static main function. In here, I'm using lifecycle library, which I also developed. The lifecycle library has this factory injection. Whenever I want to create new instance of a class, instead of using the new, I'm using factory inject. It allows me easily implement singletons. So screen control is a singleton. It's just an interface, empty interface. And whenever it's going to be injected, it's always going to be the same instance. So let's see what it does. This is just a setup. And then initialize is the first method called by the Java fx. This is fxml in here. So this is the layout. It has a screen container. And let's see how it works. So we have all those buttons at the top, which is the toolbar. And then when we click on one of the home button, for example, then we are calling to move to main command. Let's see what that does. So it's a command interface. It has the execute method. So this is the move to main command. It's basically have a logic that decides which screen to open. It can be a password screen, a login screen, or a welcome screen. Let's look what screens are. So there is a screen controller, which is a singleton. And it has a list of screens. Each screen is an instance of the class screen. And you need to provide for it the layout and say if it's going to show the toolbar. Toolbar is the home button, the smart contracts button, and just those buttons. And then the ways that you use it, there is a logic here that decides what screen to use. And then we hit screen open, and it opens the screen. So it's very easy to add new screens to this setup. All right. So after we move to the main screen, actually let's look at the main screen. This is its layout, and it has main screen controller. Main screen is that screen. So when initialize is being called, initialize is fxml method. For things that it's loaded when the controller is loaded. This is fxml framework. So I'm setting the text for wallet address, which is the public key of the wallet model. Wallet model is yet another singleton in the system. Do you see the ease, how you can easily inject those classes? For unit tests, you can also easily mock them up. You can register for factory. So each time when wallet model is injected, you can have your own extended version of wallet model, like my wallet model. And then you can easily mock the get public method and get public key method and basically do whatever you like there. Okay, so this is a high level overview. So this is this part. This should get you started with navigating in the desktop wallet app. Let's look now at the mining screen. Yeah, this is the mining screen controller. And I want to show you the request that I'm making to the pool. Let's see. Okay, so the miner is a miner service. When it starts, there's just something to synchronize it on the main executor thread. Okay, so on start, it sends a GET request to the pool. So the GET work request, sorry. Let's see how it looks like. It's yet another command. It has some pool data just to decide to which pool to connect. And then it takes work data, which are those fields. Then using the Coco request, you're giving it a callback. The callback it has the success and error message and error method, sorry. And then just add the require parameters. It's a REST API, and you're executing it. It's pretty simple to add new requests this way. Again, I'm not diving too deep inside this code. So whenever I want to make a request in miner servers to get started, so I'm injecting new get work request. I'm using injection so I'll be able to mock it later. Then on success, I'm getting the work data, which is work ID, step 3 hash, difficulty, or error code. All right, so this should get you started with everything related to the client side. Now let's look at the pool. So the pool server is using the base HTTPS server. It set up the REST API, so the working path will be handled by work handler. Whenever I'm sending the work request, as we saw earlier from the client side, it gets here. If I want to connect to the database, so this guy set up my connection. This opens a connection to a database, and then I can do query. The query return so it returns true or false if the query was successful, or there have been errors during the query. And it gives you the result set as a callback. So in this case, I'm selecting ID, block ID, hash from the next blocks that we are building. And I'm populating those fields and basically generating the work data to send back to the client. Then I'm doing send response, and it should be pretty straightforward. In here, I'm validating the shell. Well, yeah, I guess you can read and figure it out. So this is a high level overview. Now you know how to make requests from the client side, how to handle them on the tool side, and next tutorial we'll talk about more advanced stuff. Thank you.